In 2012, the Texas Education Agency Student Assessment Division approved new Mathematics Texas Essential Knowledge and Skills, or TEKS. These are the student learning expectations for grades K through 8, and they were introduced to our students this year. These changes increase the gaps in student mathematics knowledge because many of the SLEs that were previously taught at the high school level dropped down to middle and elementary schools. Students are currently having difficulty understanding rate of change, slope, and y-intercept due to the lack of connection to previous learning and real-life application. Up until this year, all of these topics were taught and assessed by the state in Algebra 1. The use of TI Inspires, the TI Inspire navigation system, and associated probes will make rate of change, slope, and y-intercept both more concrete and realistic in the minds of our 8th grade and Algebra 1 students. Additionally, this project will provide students with the opportunity to explore the collection, display, and analysis of data collection in our science laboratories. The use of the TI Inspires, the navigation system, and probes will not only make learning about these topics more fun for students, but will also make it clear to students how this topic is useful to them, and will also allow them to see rate of change happen before their eyes on technology that is both entertaining and familiar to them. I have no doubt that this technology will increase student achievement because it will provide for our students a way of learning about rate of change, slope, and y-intercept that differs from the norm because students respond positively to the use of technology in the classroom. Research conducted by the Institute for Mathematics, University of Freiburg, concluded that appropriate use of the TI Inspire technology can facilitate use of shared resources for collaborative learning, high student engagement, and a novel, integrated format for instructional units. Additionally, the researchers at the City University of New York concluded that Algebra 1 students taught with the TI Inspire outperformed a group of students who were taught using the TI 84s in nearly every assessment. When students use the temperature probe with the TI Inspire, students will be able to see the graphs produced on the screen as the temperature of water increases in a beaker on a hot plate. The Navigator system allows teachers to collect data instantly and wirelessly from all students' TI Inspire calculators and uploads this data to the classroom computer. Likewise, teachers can also send files and data to students' calculators wirelessly and instantly. Through the TI Inspire navigation system, students will also be able to take assessments by using their calculators to input answers to tests, which will break the monotony of the paper and pencil assessment and provide teachers with instant feedback regarding students' understanding of the content. The use of the CBR2, which is the distance probe, will allow students to see on graphs and tables how moving the probe towards the wall decreases the distance, thereby causing the constructed slope of the line to decrease. They will be able to explore how graphs change as liquid heats and cools. They will be able to compare bivariate data to determine patterns, and the expected outcome of this project is that students will eagerly participate in the learning experience, which will be one of discovery. Here are a few features of the TI-inspired Navigator system. 5 workspaces let you access content and create lessons and track student progress. And this is compatible with PC and Mac. The Navigator cradles that slips on the back of each handheld to connect it wirelessly to the teacher's computer. Is the means by which the file exchange takes place. The TI Inspire Navigator Access Point is the component that provides wireless connection between the teacher's computer and the wireless cradle on each student handheld. And finally, the cradle charging bay actually charges the calculator components and the system components without battery power. And then over here we have a features overview. A lot of the things that you can do with the Navigator system is send a quick poll to students if you want to use that as a means of giving them a warm-up. Document transfer, for the purposes of taking tests. You can actually do collaborative activities. You can actually capture the screens of all of your students on your computer, and this will update in even intervals as you adjust the settings. And so these are just incredible features. The portfolio and auto grading, also a wonderful feature that will save teachers time in grading, and it'll save students time in getting accurate and quick feedback. Here you see an example of a classroom of students that are using the TI Inspires with the CBR2s, which are the distance probes. This class greatly enjoyed the use of the CBR2s, and were able to see how the slope rose and fell as they moved to and from the wall. And it gave them a better idea of how quickly they had to move as they had to compare their distance with time. This young man was very, very proud of how close he came to actually matching his movement to the graph that was established by the TI Inspire. He did a really good job. Students will be able to experiment with the use of these probes to see how increases and decreases in distance and temperature affect the rise and fall of graphs. They will be able to explore what constitutes a constant rate of change and determine the meaning of the y-intercept. The best part is that teachers won't have to tell them. They will see it for themselves with every experiment and with each experience. According to the learning pyramid produced by the National Training Laboratories, students will remember about half of what we discuss, but they will remember 90% of what they practice and teach each other. We also expect that the time that it will take for students to grasp and master these concepts will be reduced, as indicated by common assessments and district benchmark tests. Instructional methods included in this project are facilitator-led class discussion, lecture demonstration by the teacher, Socratic questioning, informal debate, construction of summaries by students, use of pre- and post-tests, interviews, laboratory experiments performed by 2 or more students, individual projects, individual laboratory experiments, student construction of diagrams, charts, and graphs, problem solving, surveys, service projects, peer teaching, coaching, group dynamic techniques, and differentiation, informative and summative assessment. Process standards involve students' abilities to transfer learning to a real-world context, problem-solving, making connections to other content knowledge within the curriculum and beyond the curriculum, analyzing mathematical relationships, and being able to communicate and explain mathematical ideas and relationships. Anticipated limitations of using this software program are awareness and functionality and capability of the TI Inspire Navigator system, as well as teachers' reluctance to use the technology because they don't know how it works. And these things can be addressed through training, as well as training for students in terms of how to care for the technology and how to respect the value and the cost of the technology that was afforded. And that will help them to better understand content knowledge in both math and science. The generation that we are currently teaching is one that loves technology. They breathe it, they sleep with it. They were born into a world of technology, and it is the language in which they speak. Nearly 90% of our students at the middle school level carry cell phones regardless of their socioeconomic status. And even though teachers may not have been taught in this manner, we must communicate in the language of this generation. This means incorporation of technology into the curriculum because paper and pencil simply isn't cutting it anymore. The probability of students being able to transfer their learning to real-world context greatly increases with each lesson that includes technology, and not just their learning, but their engagement in learning. The obtained knowledge will be useful to students during their high school mathematics classes.